Hey guys! So, today we're going to talk about a near and dear subject to my heart, types. So let's get into it. You see, just this morning, see what I did there? I didn't say the other day. Just this morning, I had such a great question from one of my viewers who asked, who basically just said, Fredrik, you go on and on about the types all the time, but could you make a video about types and kind of try to explain it, because I don't really get it. And so I thought, well, I actually have a video just like that, but nonetheless I will actually make one where we just talk like this, and I'll see if I can in words relate to you the sort of issues that a typing system is going to solve for you. Now, first and foremost, you have to now kind of just open your mind to this a little bit, because it's gonna we're going to get a little bit philosophical as well, apart from just being kind of concrete about things. So I will argue to you here and now, yes, right now, I will argue that you are not flawless. I will argue that you do not possess the potential or the capacity to have a lot of stuff in your head. I argue that over time you forget things. And I argue that whenever you have a new person joining your company or starting to work for you, you do not have the capacity to foresee all these possible ways that that person is going to use or start to contribute to your code base. In fact, I argue that the only thing that you are really good at is to do the thing that you're doing at a given moment. Now, what do I mean by that? Well, I mean that when it comes to us, we humans, we're really, really good at working in an environment where we comprehend the scope of the entire environment. In other words, if you work in a very small code base, it's very easy for you, especially if you wrote it yourself, to remember all the things that are going on in the system. And that's usually where a lot of people are. Like most people, we have this lovely new woman who started working as a developer at my company, and she's been working for years and years and years. And now she's started working with us, and I just kind of asked her, so what's the biggest difference for you now working here as opposed to working as a consultant? And she said, yeah, the projects are much bigger. And that's exactly it, guys. When you get up to professional level software development, like large scale software development, I'm not talking about a consultancy, I'm not talking about, or you can of course work on large projects in a consultancy as well, but I'm talking about when the code base grows to an enterprise level, the system is simply not flawless, it's massive, and there's tons of all these rules and subtleties and nuances to the code that you have to have in your head. Now that's not possible, because let's imagine, for the sake of argument, let's say that you start working on your application, right? And you decide that, hey, I'm going to store an email. I'm just going to save emails. And you store that as a string. Said and done. System is fairly small scale. Now, that's pretty simple. Now you start working, and since the system is very small, it's very easy for you to remember that, all right, you have to do this, because when it comes to emails, sometimes you want to validate them. Sometimes you have different operations that are associated with this email, but it's just a string. And then the system grows to a size where it's so large that over time you have accumulated all these subtle rules for the email. Because when you started out, you most likely just thought, all right, it's just going to be any email. But then you get another requirement that says, well, but an email can only contain these characters, and we only support emails from this region. It's the same thing. It can be any piece of data. An email is just an example. And you get all these subtle little rules that your system needs to know about working with an email. For example, another one is like, okay, how many times can I send an email request? Because maybe you have a threshold. Maybe you're not allowed to send more than 1,000 emails a minute or something of that nature. There's all these subtle little rules that grow over time. They don't grow, and they're not there at small scale, but they grow very, very common when they go up to large scale. So now, at large scale, your entire system now has to cater to the fact that a string or your email is just stored as a string, which means that if you, let's say for the sake of argument, you wanted to change that email, you wanted to change the name of the email or the model that's storing the email, well, hopefully, since you're not in a typed environment, you will find every single reference to that string. Because if you're passing that email as a parameter into something, or you're allocating a variable with that email, you have no idea where all of that is used. Doing a search and replace will only get you so far. And if it's a really large system with a lot of complexity, where you have all these possible ways that this string can be used, you're kind of screwed. This is one of the biggest and worst problems that you will have when you're working in a large JavaScript code base. That's why I keep telling people, JavaScript is great until a certain point, but when you get to a certain size, you need something like TypeScript, because when the code is that massive, you can't hold everything in your head. You can't remember all the rules and all the things that are associated with this specific type. I mean, think of it as, we have a type for string. Why do we have a type for string? We already have character arrays from C and C++, but we created a type for string because there are all these operations and all these subtle things that we want to be able to do with this type. And I argue that let's take this example of the email. If you had created an email type instead of just using a string, now you have the ability to change the rules. In other words, you can validate whenever somebody if you take in the string into your email type, you can validate that it is an email. You can set all kinds of rules. You can make sure that it has the correct amount of characters and yada yada yada. All of these things can happen at the creation time of that type. But if you don't do that, you have to, all the code around it has to cater to the logic that is associated with that type or with that string. And that's where the power of types come in, because when you have a type, you can declare that, all right, if somebody uses this piece of information or this type, these are the rules that are associated with this type. And that's true through all of the system. That's the power of types, because now you can just be secured in the fact that if you need to change the semantics of your type, you can do so very easily, and it will cascade through the whole system. And if you broke something, because that happens all the time, especially in JavaScript, you change a property, you remove a property, you rename a property, you do something like that. Now, with the type system or TypeScript, your tooling and your compiler, if you will, can help you figure out, all right, did you break something? Did something, because of what you just did it break? As I said, that's not usually a problem at small scale, because you can hold the whole system in your head. But when it's really, really big, or you're new to the code base, this is extremely useful, because now you can change the semantics of your types without fear of breaking everything else. Or at the very least, if you broke something, you can be informed that happened. In a loosely typed language, you can't. And that's why types are so important. That's why I tell you, things that, take Twitter, for example, who moved over from using Ruby over to actually using Scala. Now, why did they do this sort of thing? Because at that sort of scale, a type system is almost critical, because you can't, when such a large system is being maintained by hundreds of people, there's no way for every person to have it in their head that, oh yeah, an email is a string and it's going to work this way. But if you have a type, you can, as a team or as an organization, say, this is what the email means to us. And you can even create subtypes of that email to say, oh, it's an email from Denmark, it's an email from Sweden, it's an email from America. Like, you can do all these kinds of, you can create rule systems around your types that are semantically important to your system. That's why types are so important, and that's why the really large companies use a type system. Take Facebook, for example. They had PHP originally. Now they have another system on top of that, and they did this sort of migration for the same sorts of reasons. Because at small scales, loosely typed languages are awesome to work in. You can work very quickly. But when you get up to a point where you're changing code more than you are creating new code, that's when this becomes important, because adding code is easy. It's easy for you to just add something, but if you're changing that something that's already there, you have to be sure that when you change something, you don't break a bunch of stuff that's already there. And that's why a type system is so important. It is the best way, in my personal opinion, to maintain a large-scale system. And I think that considering how common Java is in the enterprise world, where this sort of scale actually exists, there's a lot of people who would agree with me on this. At least that's what I think. Have a great day.